In this video, we're going to continue our discussion of derivatives, talking about implicit derivatives. Now, just in case you forgot, implicit derivatives, the reason we have these is for an implicit equation. What that means is we are trying to find in this problem that we're about to do partials with respect to z. But notice that in normal calculus problems, we'd always have like z equals or f of xy equals. That's everything we've seen so far. But now z is actually in our equation. Now, if we could solve for z, that would solve all our problems. I could solve for z, then it becomes like the derivatives that we've done just before this. The problem here is we cannot solve for z. So this is the reason that implicit is around. So I'm going to start this, and then I'll walk through the weird implicit part. So let's do the partial of z with respect to x. We'll start there. So the first thing we're going to do is we're going to take our partial of everything in our equation on both sides. Okay, my derivative of x squared y is just 2xy. The derivative of minus xz is just a negative z, because the x is the variable, z is a constant. And z is not actually a constant in this case. We've got to be very careful here. This is where mistakes can happen. I'm going to go ahead and erase that for a moment. And what we're going to do is I'm going to split this up into what's actually being said. I have x, and then remember, z is a function of x and y. So this is where the implicit part comes in. I got to take the partial with respect to negative x times z. And then since z is a function of x, I also have to take its derivative with respect to x. So that's where that part comes in. Let me scoot this over. Now I do the same thing for this next part, except for, thankfully, the 2y is a constant, but that z squared is what's going to hold us up. So we could break this down again if we wanted to. Let's just do it to keep things consistent. I could do that times z squared. And we know how that's going to work out. Plus 2y times the partial of z squared now. Cool. And then the right side, it's just negative 3. We get that big 0 there. Okay, so now I'm going through, and I'm going to take the partials that I can. So I got 2xy. This first one, the partial of negative x with x is just a minus 1. So I get negative z. Okay, the next one I get minus x, and this is the weird part. I don't know what z is. So I'm just going to call it the partial of z with respect to x, which is what I was trying to find. Right? So we're going to end up solving for that variable. The next part, the partial of 2y with respect to x is 0, so the whole term goes to 0. And then my last term, I got 2y, and then I take my derivative. The derivative of z squared is 2z, but it's a chain rule, so I got to add on a dz dx. Just like implicit back in Calc 1. We're just dealing with now multiple variables. Okay, now we need everything that has a dz dx on the same side and everything else on the other. So I got negative x dz, I'm going to use the partial one, dz dx, plus 2y times 2z times dz dx. Okay, and then I can keep going. Okay, this is equal to, now I'm going to move everything else on the other side, so I get z minus 2xy. That's moving those over. Now notice I can solve, or factor rather, this dz dx. These should be partials. It's a bad habit. Okay, dz dx with the partial, x with the partial, times, okay, negative x plus 4yz equals z minus 2xy. And then now I can solve for the partial of z with respect to x is z over 2xy, or z minus 2xy over, I was ahead of myself, negative x plus 4yz. All right, that is how you find that one. This can become messy very quick. The common mistake that I see, that I actually do myself, is I forget to do this part. Because I'm like, oh, z is a constant. You know, so I'll skip over that, and I'm like, and then I realize, oh, z is not a constant. Z is a function of x and y. So be very careful that when you take those derivatives, that's where the implicit part comes in. All right, we did it one direction. I'm going to shrink this down so I have room for the next part. Okay. Now they want us to do partial of z with respect to y. So we do that same thing. Okay, I'm trying to write small here. The partial of y of everything. All right. A lot of things are going to work out the same way. This first one with respect to y is just an x squared. It's a constant. And then I'm going to go ahead and break this one down so I don't mess it up. dy of negative x times z minus x times the partial with respect to y of z. All right, scoot this over. I always start too far over there. Now I have to do the partial with respect to y of 2y times z squared. This is just the product rule. And then 2y times the partial of, with respect to y, of z squared. And then that right side is just 0, thankfully. All right, let's go through and do these partials. Okay, I got x squared. This whole term here goes to 0 because there's no y in my argument of my derivative. Right, then I got minus x times, right, the derivative of z with respect to y is just exactly that. I don't know. That's what's in question. Plus, okay, the derivative of 2y is just 2 times z squared. And then the last thing, we have 2y times, okay, the derivative of z squared is 2z, times it's a chain rule, so I get dz dy equals 0. So now I'm going to get the terms that have dz dy together. So I got dz dy times negative x plus 4yz equals, and I move those things over. I got negative x squared minus 2z squared. And then I have a lot of negatives, so I'm going to do a trick here, and I'm just going to change every sign by a negative. That's multiplying top and bottom by -1. So I'm going to get x squared plus 2z squared all over x minus 4yz. I just changed every single sign just to make it prettier. So there is my derivative of z with respect to y.